This is project 2 for CS7344, Computer Networks and Distributed Systems. I'm Orion Koepke and will be guiding you through what I did for project 2. So for this project, I decided to analyze my home network and make some changes to the wireless access point to try and make it better. I kind of wanted to do this project because I thought it would kind of give me some real-world experience analyzing network traffic and networks and just how to make them better. I feel like that would be valuable. Those would be valuable skills as a software engineer. And you know, on the side, maybe it would improve my home network speeds. So for what I learned for this project, so what I self-taught myself was NetFlow through this NTOP-NG program. Setting up Raspberry Pis, which became necessary, which I'll show in a minute, and then just configuring my home network to see all the traffic, which was a bit harder than I thought it was going to be at the beginning. So let's explore kind of how I set it all up, which was kind of the hardest part of the project, to be honest. So this was my original home network setup, just a modem connected to a wireless router, connected to these end devices here. And originally I thought that I could just get on my laptop or my desktop and I would be able to kind of just see all the traffic going over the Wi-Fi, whether it was intended for my specific device or not. But that seems that it's not true. If my network card had supported monitor mode, I might have been able to see it all, but none of my computers or laptops supported that mode, so I had to get a little more creative. I went ahead and changed my home network to look more like this. So what it is there's the cable modem as before, connected to this wireless router, which connected to the Raspberry Pi over Ethernet, and then connected to a wireless access point over Ethernet again. And then that wireless access point would connect wirelessly to all the end devices. So my Nighthawk wireless router, we were not using the wireless mode. I turned it off. And I configured the Raspberry Pi to act as a bridge by connecting the Nighthawk wireless router into the Ethernet port, and then having a USB to Ethernet port adapter connected to the Raspberry Pi, which connected to the wireless access point. Because the Raspberry Pi acted like a bridge and was in the middle, all the traffic from the end devices going out to the internet and back had to go through the Raspberry Pi. And so I put that NTOP-NG NetFlow program on that, and it was able to see all the wireless traffic going back and forth. This actually took a little bit of time for me to figure this out and get it all set up. But once I did, it all worked out. Here, I'm going to kind of just show you a little bit of a demo of the NTOP-NG program and just kind of go through some of the different dashboards and things that you can see on it. So we're going to hit play here. Here you can see the main dashboard. And then I'm going to go to the live flow so you can see all the different things coming in and out of the network. Here you can see all the different hosts. And specifically, here's all of my hosts that are connected to my local network. Then we can see the geographies map here, so you can see the different servers that we're connected to outside of my network, connected to Netflix or different things and their locations or approximate locations. Finally, you can kind of see a usage of the network over time. The blue being your downloads, and the green, which you can't really see much, being uploads. And so, yeah, that's pretty much a demo of that. Next, I'm going to kind of show you here. So I actually set up 2 Raspberry Pis for this. One, like I showed before, called Raspberry Pi. That was the host name. And another one I set up as an actual end device. I called it Apple Pi. And so what I did was I set up a simple Python HTTP server on Raspberry Pi that would just provide some data, about a megabyte's worth of data if you called it. And Apple Pi every minute would go hit that server and pull a megabyte of data across the Wi-Fi network. And I had to do this basically just so when I changed settings in my Wi-Fi, I could see whether it was better or worse. It's kind of hard to do that with just in TopNG or some NetFlow because I need continual predictable traffic to see whether the traffic got slower or not. And so this is what I did for that. Here, we're just going to see a little bit of a demo of the couple endpoints that I had implemented on that Raspberry Pi. Let's play. And here you can see the ping endpoint. It's just going to return a PONG message. But then I also have this download endpoint, which will return the megabyte of data. And you can see here, if you look at the bottom where it says raw content link, that's roughly a megabyte, or 1024 times 1024 bytes of data. So next, we're just going to kind of look at the network analysis here. So this is just the things that I could determine by just looking at the top in TopNG dashboards, insights I was able to gather. Here you can kind of look through and see peak usage times. The blue, once again, is the downloads. The green are our upload speeds at different times. And you can kind of just see, not rather speeds, but how much was going through it at one time. And you can see that many times there's just nothing going through it, and those did correspond to times where we were away or asleep. And then peak usage times are normally in the evenings. Once me and my wife got home, started watching TV, had our phones connected, and those types of things. Then I was also able to look at the bandwidth hogs, so the different devices that kind of hogged up the network. Not surprising, the Raspberry Pi and Apple Pi kind of took up most of it, or were the biggest rather, just because they're continually pinging each other back and forth, downloading a megabyte of data. But after that was the smart TV, which kind of made sense, my iPhone, and then my main desktop. Next, we're going to go through some different network changes that I made to the Wi-Fi network to see if it would improve the speeds. First, I took a baseline, and here you're seeing a graph of every minute Apple Pi was pulling that megabyte from Raspberry Pi, and it was recording how long it took to pull that megabyte. And you can see that it never went, it never got to 1 second to pull it. If you look on the left axis there. Now you will see a couple times where it took 0 seconds, and those were just where it returned with an exception right away for one reason or another. I'm not 100% sure why. It only did it like 2 or 3 times in this whole span, but that was baseline. Next, I went ahead and enabled orthogonal frequency division multiple access, or abbreviated OFDMA, which is supposed to enable multiple users to transmit data simultaneously, and thus greatly improve speed and efficiency. I didn't see that. In fact, it took sometimes longer. We have here that it took 2.5 seconds, well, over 3 seconds, at least once to pull that megabyte of data. So I didn't see that personally. I do know that this OFDMA requires the clients to also be able to do that, and maybe my clients weren't able to. Next, I also enabled TWT, which is target wait time, which is supposed to allow the routers and clients to negotiate the periods of transmit and receive. This is supposed to allow clients to sleep and preserve battery life, specifically iPhones, well, just any phone in general. And I did not see improvements on that. It looks like it actually hit 4.5 seconds to download that megabyte at one time. And that kind of makes sense since the TWT would probably wait longer. And so it may not be geared for efficiency, but to save that battery life. So in conclusion, OF, DMA, and TWT didn't seem to make my network any faster. And that kind of makes sense for TWT based on what it's supposed to do. OF, DMA, I would have thought would have made it a little bit faster, but maybe none of my devices support it. That's it for me for project 2. Thank you for watching.